We're going to take what we've learned about balanced chemical equations and the mole and bring it together into a concept known as stoichiometry. Stoichiometry is used by chemists so that when we go into the lab, we know the exact amount of materials we need of our reactants, as well as being able to predict how much material products we should get from that reaction. The first thing we need to do in order to make these kind of predictions is to have a balanced chemical equation. Below you can see we have a skeletal equation of sodium and oxygen forming a sodium oxide compound. But you'll notice this isn't a balanced reaction. So we need to balance it. So we'll go back and we'll draw our table of reactants and products. We'll list out our elements here, sodiums and oxygens. And what we'll do is we'll start to write out our equation. Sodium solid plus oxygen goes to sodium oxide. There we go. Now we can start balancing. Well, you can see on the reactant side I have one sodium, but on the product side I have two sodiums. So I need to balance the sodiums by putting a 2 on the reactant side. So now we have our sodiums balanced. Next up is oxygen. Oxygen, we have 2 oxygen atoms as reactants, but we only have 1 as a product. So in order to get the oxygens to balance, we need to increase the number of sodium oxide molecules to 2. Unfortunately, by doing this, this also changes the number of sodiums we have to 4. So we'll have to go back and rebalance our reactant side and change that to 4 as well in order to get to our overall balanced chemical equation. Now that we have our balanced chemical equation, we can then start to look into how many grams of oxygen I need in order to completely react 14.6 grams of sodium metal during the course of this reaction. Well, when we do these types of problems, again, we always start off with something tangible we can measure, in this case mass. So we're going to start with 14 grams of sodium. Now, we don't work with grams very long in chemistry. We always like to get to the mole. So what we're going to do is change our grams of sodium over to moles of sodium. And so looking at the periodic table, I can see that I need 23 grams of sodium to have 1 mole of sodium. Now that I've got my sodium in terms of moles, I can use the mole-to-mole ratio from the balanced equation here in order to change from sodiums over to oxygens. So I'm going to do just that. And the mole-to-mole ratio comes from the coefficients of the balanced equation. In this case, I'm interested in the sodium to oxygen ratio, so I can see from the balanced equation it takes 4 moles of sodium to equal 1 mole of O2. Now that we're left with moles of O2, what I can do is I can use the molar mass of oxygen to get back to grams of oxygen. So I can say 1 mole of O2 is 32 grams. So in order to react 14.6 grams of sodium metal, I find I'm going to need to have 5.08 grams of oxygen gas present to completely use up my sodium.